Hey everyone, welcome back to Learn with Crazy Engineers. So in today's video, we are diving into one of the most fundamental material tests in engineering. Whether you are a student or an engineer or just curious about how materials behave under stress, and this video is for you. So grab a notebook and hit that like button and do a subscribe and let's get started. So if you want to know about tensile test, let me give you some example. So tensile test means where the sample is pulled apart until it breaks, which means we take a sample and we apply tension force at one end and fix another end. So the tension force will be gradually applied and the test will be conducted until it breaks. So why we do that? Because this kind of test help us to determine how strong a material is and how much it can stretch. So based on this test outcome, we can calculate the material yield strength and the material's Young's modulus and its ductility behavior and when the fracture will happen and also the UTS. So now let's break down the stress strain curve so that you can get the idea. So if you see here, you can see the 5 points. So from here, you can see the proportional limit and you can see the yield point where the plastic deformation starts to occur. And also you can see the UTS, which is nothing but the ultimate tensile strength, where the maximum stress the material can take, and then necking where the localized reduction in the cross section will happen. After that, the fracture will be occurs. So this kind of key points we can get it from the stress strain curve, and from this curve we can also calculate the Young's modulus and we can get the yield strength and we can calculate the UTS and also the ductility. Why we need this material property? Because we are going to use this material property for conducting some simulations like sheet metal forming process. Now I am going to walk you through a step-by-step tutorial to model a tensile test in LS-DYNA, and we will do it without considering a fracture. And also we will be following the ASTM standard. I have already created a 2D geometry for you. So let's dive right into the meshing and model setup. Hey, and if you want to install the AutoCAD for free, please check out the description and you can download it for free. Okay. First, let's open the LS-DYNA. So we will begin by loading our 2D geometry in LS-DYNA because our goal is to make a 2D symmetric model. Then we will convert that into a full model. But in my case, I told you I already have the dimensions in the previous slide. So you can note down the dimensions so that we can directly input that into our LS-DYNA tool. So for that, now on the right hand side, you will find out the mesh tool option. Click on that. So next, open the subtool menu and select 2D mesh tool. This is where we will be doing all the meshing work. Now we are going to model half of the specimen and then mirror it later to build the full geometry. This is not only faster but also save the time for us. Now let's begin by converting the line into edges. This allows us to define the number of elements on the edge. So make sure that you will define an equal number of elements on opposite edges because this is important to get a proper structured mesh in the model because it will improve the simulation accuracy. So now you can see we didn't get the proper mesh near the curved edges because we didn't divide the geometry properly. So let's do some changes by adding more edges into the geometry and do the meshing procedure again. So it looks perfect now. Now that we have meshed the half of the model, let's convert into the 3D model. So for that, first go to the element tool and select the transform option. From there, you can select use the mirror function to create the full geometry by duplicating the symmetric half. Once you mirror the geometry, don't forget to go and remove the duplicate nodes, because if there are many duplicate nodes, then you will get the problem in the post-processing or even when you run the input file. So make sure that there will be no duplicate nodes. Then go to the element generation option. From there you can choose options to convert the 2D into 3D by adding thickness and a number of segments in the thickness direction. You can add more segments as much as you want, but if you choose like a 1 to 7 or 1 to 3 or sometimes 3 to 7 will be perfect, but it's based on your wish. But here I selected 1 because I want to make the simulation very fast. So if you for your convenience you can select 3 or 7, that's your wish. Now it's time to move into the keyword manager to set up the simulation. Here's what we need to define. So first we have to define the element type, and then we have to define the material property which we calculated from the tensile test, such as Young's modulus or its UTS value or its a fracture point, and those kind of material property has to be defined here. Then we have to give the load curve, like based on the load displacement, like what kind of boundary condition we are going to apply here. Then we will use the database to store the stress and strains and displacement so that we can see those values in the post processing. And then finally we will do the control card, where we will give the time step and termination time and other parameters to control the simulation. So these are the 6 important things we have to define in order to get the proper keyword for running our model. So once you did all this procedure, you have to do a model check, because if you do a model check, you can find out the error if you made any in the keyword file, because this will help you to achieve a proper keyword file. Otherwise, if you run the keyword file, you might get a problem in the running, and you might confuse like where you get the problem. So better you do a model check and then save the file and do a running. So once everything is defined, you can save your keyword file and run the simulation using LS-DYNA solver. Now you can visualize the results in LS-DYNA tool. So now you can see the results. We got exactly what we gave it as input, and it looks very similar to the experimental data, which means that we created a proper input file and we solved the problem. And that's it. You have just to model a complete tensile test simulation without fracture using LS-DYNA, starting from 2D mesh to full analysis ready setup. And also make sure that you check the mesh quality before you solve, and also you save the keyword file and do a model check and then run the file. And if you find this video very helpful, don't forget to like, subscribe and comment below if you want more content on mechanical testing. And thank you so much.